Hey YouTube, this is David and Kristen from Johnstone Supply and the Bolson Group. Today we're introducing Jerry's first tech tip.
Today Jerry's going to go over nitrogen flow and why it's so important when brazing. Enjoy!
Hi, I'm Jeremy Peak with Johnstone Supply, the Bolson Group. I'm the Technical Service Advisor, and today I'm going to talk to you about the importance of nitrogen flow when you're doing HVAC systems work. Most importantly, we have three different settings for nitrogen flow. We call them braze, purge, and test. Now, if you're using a nitrogen regulator, you have to use a nitrogen regulator in order to get their brazing flow rate correct. We flow nitrogen through a system brazing at 1 to 2 cubic feet per hour. This is so that we have displaced the oxygen in the system and provide protection for the inside of the pipe. We purge at 4 to 6 cubic feet per hour. That's when you're done your brazing. You want to purge at 4 to 6 cubic feet per hour, and then you'll go, after that, you'll go to a testing at anywhere from 250 to 600 psi. The 250 psi would be for R22 systems, all the way up to 600 psi for mini split systems. That's the manufacturer's recommended pressure test. The purpose for brazing with nitrogen flow is because at this point with R410A, we use POE oil, polyester oil. When we had R22 systems, we used mineral oil. Mineral oil was really not a very good lubricant. However, it was something that worked with the system and R22, and R22 was capable of carrying it around the system because of the chlorine in R22. Since we switched to 410A, and it is an HFC refrigerant, it has no chlorine in it, we had to come up with a lubricant that would work with a fluorinated hydrocarbon. The POE oil is a fantastic lubricant. It lubricates the system very well, but we have to get it around the system in order to lubricate all of the parts, including the compressor. One of the other qualities of POE oil is it's also a very good solvent. So if we're not protecting the pipe on the inside, then we're going to get oxygen that's going to burn off and scale off the inside of the pipes. As the POE oil is transported through the system, after we energize the system, it's going to scrub that inside of that pipe clean. It's going to take all the scale and the slag and the buildup and deposit it either in your compressor crankcase or in your TX valve. They're the smallest points in the refrigeration system, and it's doomed to failure. One of the other problems with POE oil is it's very hygroscopic. It will absorb moisture very rapidly. We cannot have moisture in a refrigeration-based system because that will eventually lead to acid, the production of acid, and a system burnout. So, the purpose of flowing nitrogen is to protect the piping and the components, to remove moisture, and to do finally a leak check. We offer all kinds of regulators with nitrogen systems. This particular regulator here is a Western regulator. It's a little bit different than the traditional nitrogen regulators because it is an orifice-based regulator and not a diaphragm-based regulator. You'll notice I only have one gauge on this regulator. It just tells me how much pressure I have in the tank. Basically, it is conducted by a 4-position switch at the top where I can actually set my brazing at 1 to 2 cubic feet per hour. I can simply turn it to purge where it will flow 4 to 6 cubic feet per hour, and then I can turn to test, at which this particular regulator, this is the 500, this will give me 500 pounds per square inch test pressure. There's no dialing in, there's no, it also has a very handy hand wheel to it, there's no mechanical connection, it just simply comes off. These regulators are available at our Johnstone Supply branches. Hey, thanks for watching. If you want to see more videos, please hit subscribe. If you want to learn more about this subject, click on the links in the description. And again, thanks for watching.